What was Earth like 2 billion years ago? It's hard to imagine, but back then, our planet looked and felt nothing like the world we know today. There were no forests, no animals, and certainly no humans. The continents were still shifting and colliding. The atmosphere was thick, strange, and hostile. Yet, even in this seemingly harsh environment, life was quietly changing the planet. These changes set the stage for everything that came after. So today, we're going to dive deep into this fascinating chapter of Earth's history and discover how life survived, adapted, and transformed the world. Two billion years ago, Earth's atmosphere was vastly different from today's breathable air. Oxygen was scarce, almost non-existent in fact. Instead, the skies were heavy with gases like methane and ammonia, making it a dangerous place for any form of life that needed oxygen to survive. The oceans, covering most of the planet's surface, were filled with simple, single-celled organisms that thrived in these conditions. But there was something happening beneath the surface, a quiet revolution that would change everything. Tiny organisms called Cyanobacteria were starting to perform photosynthesis. That means they absorbed sunlight and used it to convert carbon dioxide and water into sugars, releasing oxygen as a waste product. It sounds simple, but this process was revolutionary. Over millions of years, the oxygen they produced began to accumulate, slowly transforming the planet's environment. However, this oxygen didn't immediately flood the air. At first, it was absorbed by minerals in the oceans and seabed, forming iron oxides and other compounds. Scientists call this the Great Oxidation Event, or the Great Oxygenation. It's a turning point that reshaped both the atmosphere and the ocean chemistry. As oxygen levels increased, the consequences were dramatic. Many life forms that had evolved in oxygen-free environments couldn't cope with the new conditions. These anaerobic organisms either adapted, found refuge in oxygen-poor areas, or simply died out. This mass extinction event is sometimes referred to as the oxygen catastrophe. It's a reminder that even a slow change in the atmosphere can have massive effects on life. But oxygen didn't just destroy life, it enabled it. Aerobic organisms, which could use oxygen for energy, began to thrive. With oxygen, cells could generate much more energy than through fermentation alone. This energy boost allowed for more complex processes, larger cells, and eventually multicellular life forms. Interestingly, scientists believe that this surge in oxygen set the stage for major evolutionary leaps. Life became more efficient, more diverse, and more resilient. Over time, this would lead to the explosion of life forms we see today: plants, animals, and even humans. But it wasn't just the atmosphere that was changing. The planet's surface was also going through a dramatic transformation. The continents weren't fixed in place like they are now. Instead, they constantly drifted, collided, and broke apart due to plate tectonics. Volcanoes erupted frequently, releasing gases and minerals into the environment, fueling chemical reactions and influencing ecosystems. These geological activities affected the oceans as well. Nutrients like iron and phosphorus were washed into the seas, feeding the growing populations of microorganisms. Even though the oceans were still harsh and inhospitable by modern standards, they became rich nurseries for life. And then there's the surprising discovery of early multicellular life. Fossils found in Gabon, Africa date back to about 2.1 billion years ago, just after oxygen levels began to rise. These fossils suggest that some of the earliest complex life forms may have appeared far earlier than scientists once believed. It challenges our understanding of how quickly life can adapt and evolve when new resources and environmental pressures are introduced. These developments weren't just isolated incidents. They were part of a global transformation. Life, atmosphere, oceans, and landforms were all interconnected, driving one another toward greater complexity. 2 billion years ago, Earth was a world of extremes. Harsh environments, dangerous gases, and a rapidly changing atmosphere. Yet, even in this chaos, life found a way to not only survive, but to innovate and evolve. The rise of oxygen marked a turning point, destroying some species but empowering others to reach new heights. The geological forces shaping the planet's surface created new habitats and spread nutrients that fueled biological growth. These changes set the foundation for everything that followed, from simple cells to complex organisms, and eventually, the rich web of life we see today. Studying this ancient period gives us a glimpse into Earth's resilience and adaptability. It also helps us understand how fragile and interconnected life truly is. So next time you take a breath of fresh air, remember, it all began with microscopic organisms in the oceans, quietly transforming the world 2 billion years ago.